Hey everyone, welcome back. Today we're doing day 15, linked list. Linked list is a new data structure which is similar to the list collection that we know and love. But there are some differences for a linked list. Unlike a list which stores every single item in that list in a contiguous block of memory, a linked list doesn't necessarily do that. A linked list consists of node objects, where the node objects consist of two properties. The first property consists of the data. It can be a string, it can be an integer, or an object, anything that you like. And the second parameter is next, and that points to the next node in the linked list. So this contains the reference to the next node. And with that, it means that even if your nodes are stored in non-contiguous block of memory, because every single node has the address to the next node, you can simply advance across the linked list by using the reference for every single node to the next node. So that's pretty much it. So for this question, we are given an insert function on line 12. And our job is to, given the head of a linked list, as well as an integer data, we're supposed to advance through all the way to the end of the linked list and insert the data wrapped as a node object. And once done, return the reference to the head node. So let's get started. Before we continue, the first thing that we can do is import from the typing library the optional type hint. And that's because the second parameter to insert is really an optional of a node. And when the optional of a node is assigned to none, it means that the linked list is empty. The third parameter is an integer, and this will be the item that we'll be adding to the end of the linked list. And because we're inserting one thing, we're guaranteed to have at least one node after running this insert function. So before we start, the first step is to check if the head is empty, and that means is the linked list empty? And one way to check it is just to check if the head is none. If the head is none, then all we have to do is to wrap this data as a node and return that as the new head of this linked list. At line 17, after passing condition on line 15, it means that the head is not empty, and that means we are given a non-empty linked list. So then our job would have to be to advance to the end of this linked list before we perform the insertion. So to do that, we can define a current pointer, and this current pointer will be of type node, and that can be assigned to head. Once done, we can advance this current pointer with a simple while loop and check whether if the next property of this current node exists. And if that's the case, it means that there are more nodes to be advanced. So all we have to do to advance is just set the current pointer to current pointer.next. At line 20, your current pointer will be pointing at the final node of the linked list. And all you have to do is set current pointer.next to node containing the data. And once you're done, you can return the head. So let's run the code. We pass the test cases, and we pass the rest of the test cases. So notice that for this question, you do not have to deal with the inputs as well as the outputs. And that's because HackerRank was nice to define the input and output logic for us. And that's pretty much it. Hopefully through this exercise, you are better able to understand what a linked list is. It consists of multiple node objects, where every single node object consists of a data, as well as the reference to the next node in line. And we also got comfortable with iterating a linked list by using every single reference in every node to the next node. And all we did was advance to the end of the node and create a new node with the new value that we want to insert with. And that's pretty much it for this challenge. If you find this useful, please give us a like and subscribe, and we will see you in the next practice.